Okay, now for solutions to the questions to the down cell questions. And what mass of sodium in tonnes would be produced when this cell runs? So again, we're starting off with electricity information. So Q equals I times T. So 24 hours, how many seconds in 24 hours? Well, that's going to be 24 times 60 times 60. We've got 25,000 amps times the time in seconds. So 24 hours times 60 minutes in an hour times 60 seconds in a minute. That gives us 2.6 times 10 to the 9 coulombs. So then we convert coulombs to moles of electrons by dividing by Faraday's constant. Then we've got number of moles of electrons. We want moles of sodium. Well, from our half cell equation, we see it's a 1-to-1 mole ratio. That's nice and easy. So we've got the same number of moles of sodium as electrons. So if we want the mass of sodium, we multiply that by 23 and we get 5.18 times 10 to the 5 grams. Divide that by 10 to the 6. There are 10 to the 6 grams in a tonne. So that's 0.518 tonnes per cell. Now, as I hinted at before, there are 32 cells. Every coulomb of charge is passing through 32 cells, so we've got to multiply that by 32 and we get our 16.5 tonnes. What volume of chlorine gas? Well, you can go through and you can do it exactly the same as I did the previous one, or you can look at the overall equation. For every 2 moles of sodium, you're going to get 1 mole of chlorine gas. So we'll just use mole ratios on the number of moles of sodium that we worked out previously. Get that? Or else you could go through the Faraday's law stuff again separately. Once you've got the moles of chlorine, then it is PV equals nRT to give you the volume of chlorine, and of course remember to multiply it by 32 because you've got chlorine being produced in 32 cells. Energy, E equals IVT is the formula which I think we did we do it early on in Unit 3? If not, we'll be doing it. It's actually a little Q these days, isn't it? Q equals IVT. So we've got the current, we've got the voltage, and we've got the time. Now, you're going to have 7.2 volts being used in each one of the 32 cells. So the total voltage across 32 cells is going to be 7.2 times 32. Remember to multiply it by the number of seconds in your 24 hours and you will calculate an enormous amount of energy that is consumed by this cell. Now question 4 is a trick question. Why do we put calcium in the electrolyte? We put calcium in there simply to drop the melting temperature of the electrolyte. If we've got a mixture of sodium ions and calcium ions, what's going to react first? Well, of course, sodium is the stronger oxidizing agent, therefore calcium ions will not be reduced, no calcium metal will be produced. So you need to think before you plough ahead and do all those calculations.